oil and gas?
Like drawing them or building them?
Yeah.
A while ago, not directly, a while ago, JT Oil Services, I don't know if they're even still in business, but they wanted to do photo drawing. So he sent me a bunch of photos and I was going to make a drawing out of it, which is kind of cool. But nowadays, you could make, with those photos, you could make a 3D model of the whole thing. Pretty almost automatically and stuff. So
yeah,
so it's pretty cool. All right. Is that what your project is in Tech 3?
Yeah.
Nice, nice. Yeah, well, that's a great experience, I think. So.
Myself.
Okay. So, what I think. Oh, and then, we're in chapter 10 also, right? We're doing horizontal alignments and whatever. And, oh, we didn't finish that, huh? So let's finish this, and then we'll go on to our grounds crew map. I'll show you what it is, though.
Is that a final?
Nah. It's extra credit, maybe. I've never done extra credit. I'm not sure how, but not sure what it is. This thing's one of these cables that goes to the projector. Yes. I bet you it's this right here. I jiggled it and it came on. Well, no, it's not. Let's just make this start pulling out stuff. So anyway, on number 10, we started putting the station marks, right, on everything. How far did you guys get with that? Just as far as we did in class, probably, I'm guessing. This.
Oh, yeah. I don't have the boundary layer. You just have the line. I thought I had the boundary layer.
There it is. If I could let go of this without it. Don't touch it. Okay.
We're going to use ArcGIS?
Actually, no. I'll use Google Earth. I just wanted to show you what the project is for the grounds crew.
Is that outside? Outside?
Yeah, the people that maintain the
Yeah.
grounds, the ground.
What side is it? What they're thinking of?
Oh, I'll show you. Should I record this for? Yeah, probably.
You want the south side?
All right.
East, west, and south.
It's by that graduation plaza. Where are we? Where are we here? Grand Junction. Okay, I can't live like this. I have to do not automatically tilt while zooming. Thank you. Okay. There we go. All right, so we're right here, right, by the little theater. So we're in this room over here. And just if you go out the back door of the little theater and come around the IT building right here. I think that's the IT building. No, this is the IT building with the copper roof. Yeah, yeah, yeah. So down here's the security, and then over here is their drainage problem. This lawn area, it gets flooded. In fact, you can kind of see where that is, where it's kind of trying to drain, and they want to, manage that or whatever. So, and then it just drains into the parking lot or whatever. I think they want to get it out over by the road here, where it can drain off of. I think there's actually some drainage down here. So they want to be able to, I don't know, do some, maybe even a culvert or something. But anyway, I don't know what they want to do.
And this was like plumbing.
See what?
Plumbing. Kind of like plumbing.
Yeah, yeah, but they would have to get bulldozers and just change the shape of the, so when water is on it, or dig and put some plumbing, right? Some drainage pipe in there, like a culvert or something like that. So I'm imagining that they would just kind of reform the land, like push the dirt up and make a channel for the probably. I don't know what they're thinking, but they don't either until they get like a nice map that'll tell them, right? So there's a couple ways to do it, right? You guys are in the surveying class, so you could go out there with the total station and just put the prism every 10 feet and just get elevations everywhere, right? And then we've already done that in chapter 8, where you have a bunch of surveyed points. You can make a surface out of it and make a contour map right off of that, right? But as it turns out, even Google Earth knows the elevation for that matter, right? Sort of. It's not good enough though, right? This elevation here it's not accurate enough to make like those kinds of decisions, like, okay, we just need to move here or whatever. That, these are like within 10 meters. So you're not getting, I can put my cursor over it and it'll tell me it's an elevation of 5,634 feet, right? Yeah. Well, yeah, and there's only 2 feet difference over here and stuff. I don't know, it might be accurate, but it's probably not, right? Okay. So what we'll do, I think, is get LiDAR data, which is already there, and we'll just pump it in, make a map for them with the LiDAR data. You can make a contour map and just give it to them. So I think it'll be pretty quick. And I'll show you where to get the LiDAR data and stuff. And we will use ArcGIS for that because it's easy. So, okay, well anyway, that's later. It'll be fun. And what's nice about the LiDAR data also is the trees and stuff won't get in the way because you can use a bare earth model and it'll cut out the trees and stuff. Anyway, yeah, we'll chop the trees down virtually without actually, no actual trees were harmed in this experiment. Okay, so we were on Gee, if AutoCAD would start. Okay, here we go. So let's open up, weren't we on, yeah. How come I don't see it here? Yeah. Huh. So I have to open it. I think I put it.
Is that on the computer?
It is. Yeah. And the one that we got, I don't know, had you started that one yet? I think I put the record. Did I post? Did we record that for you? No, you were online when we did that, right?
Yeah.
Okay. Okay. So went Monday.
Okay. No.
Okay. Yeah, I think so. Yeah. All right. Let me see if I can pull it up. So we drew the road according to the instructions anyway. And then so I got to figure out which one. If you hover over it, right, it'll tell you, yeah, this one was done in 2010. 2018. Yeah. I wonder where I put that. Yeah.
Why do we have like curves and roads instead of one straight through?
Oh,
Is there a specific reason they have curves?
yeah. Yeah.
To help the road or the gas companies? Something like that?
Well, it's actually the other way. By bending the road, right, it's longer, right? But it's also less expensive to move the dirt. It's very expensive for those bigger machines to move dirt around. So
Oh, that's
yeah, you can't just blast through hills and go through valleys and stuff like that and fill it up, you know. Right. Yeah.
Sometimes it's like elevation type of deal, and I think it's probably usually drive this one instead of going straight up.
Right. Oh, yeah, that's a good point also, which I didn't mention, was another reason why you would want to, you know, like switchbacks on a hiking trail, right?
Yeah.
You do need that distance to cover that, because there's certain codes, I would imagine, certain regulations, I don't know what they are, but for roads, the steepness of roads, right? They get more dangerous the steeper they get, for that matter too. So definitely. And for trucking, especially for trucking, going down the hill, especially brakes and whatnot.
So they have what is that called? The breakaway?
Yeah, runaway ramp or whatever. Like, yeah, you lose your brakes or whatever, and yep, very, very good. Yeah. Yep, there's lots of, oh, here it is. I wonder if I just saved it on the wrong, let's see. Let's just see. No, that's not it either. Maybe I didn't save it. Dang. Because it's not in my, yeah, this is the original, right? I'll just start with this then. Gee, that's so weird. Save as. And I'll put it in my folder, H drive, drawings. Okay. Yeah, likely. Anyway, I'll just redraw this real quick. The line and the units are, as we talked about before. So I need to go 710 tick. Got to type in the tick, or else it'll just be inches instead of feet. And then units. Type in units, and then you can set, there's architectural, there's engineering. Both of those use the foot tick symbol to distinguish between inches and feet. So that's nice. Point B, north 2430, right? So 550. So I'm going to type in 550 tick at an angle of north 24D 30 minute tick east. Okay. And then point B, yep. And point C is 620, so 620 tick at an angle of north 3925 west, and then straight up to the top of the map. So that's what we did yesterday. I mean, Monday. Oh, and then we filleted, right? We used the fillet with the no trim option. So no trim. And then the radius on the first one was 200 tick. And then the radius, so are 300 ticks, feet. Yeah, 300 foot. We'll radius that off. There we go. I also, we talked about layers a little bit. So there is a road center line layer that all that should be on. Then we have the road. I'm gonna make that a little thicker. The road out, the side of the road, the road boundary, and maybe a different color. This deep blue here, because it's a white background for me. And oh, a notes, an ano layer. Sorry, what? Right. So a point of here's this right here, the end of these two lines. That's the point of intersection where the lines of the curve, that there's a curve in between them, meet. So PI, the point of intersection, is a nice point to survey, because then the drafter can just draw to the point of intersection, and then you can just fill it like we did, and then you got this nice road drawn. Otherwise, it's kind of tricky to draw the arc not knowing that information. That's why you have, in the curve data, you have, like in the book, we talked about the chord distance and chord bearing. You could draw that chord and then draw the curve with that chord also. So that's useful information as well. So. Okay, so I set up some layers. I do want to freeze like these. So I'm going to go to the road center line layers, because we're still working on that. Actually, I'm going to move to the annotation layer and freeze these index and intermediate contour, and the text for that matter. There. Oh, but before I do that, I got to select all my road stuff. Yeah, we're going to show that. Right. So I'm going to move these guys to the road center line layer, and then freeze the intermediate contours. There we go. So that's more like what I was trying to do. Okay. So now I'm on the annotation layer, and I'm going to put the station marks. That's where we kind of left off on Monday. So the first station mark is 0, 0, right at the intersection of this road. Let me move this road over. Okay. So I'm going to just draw a line perpendicular to this on that annotation layer. Oh, yeah, it's extra thick too, isn't it? Should probably change that. Make it 40 feet long. So that's actually, the road's supposed to be 40 feet wide. So I'm going to offset it 20 feet on both sides so that that tick mark will stick outside the edge of the road a little bit, which I think is fine. And we'll see if it's fine, but it'll be fine. Let's go default thickness on that guy. Okay. There, that's more like it. And I'm going to turn off the line weight thing. It's a little easier to see. Okay, and for the time being, for the next few marks, I can just offset this line because it's going to be, because it's perpendicular. Is it really? I don't think I got that perpendicular, did I? I wasn't paying attention. There's perpendicular, and 40 tick. Okay, now I can offset this thing 100 feet, right? So every full station is 100 feet, so 100 tick. Have I said that enough? Don't forget your tick. Okay. You could also use the copy command and just go every 100 feet. But you get to, here's where you get to this, and that's no good, right? Because that's not on the center line of the road anymore. So that one's no good. So I got to figure out, you know, where on this curve do I need to put my tick? Right. So, but I could copy this one. Right to the point of curve, right? Point of curve being right there where the curve starts. And then I could put it over here, but it's not going to be perpendicular anymore. So. Although I could do this. Draw a line right there. That's perpendicular, right? Because I drew it to the center. And then, I don't know, draw a circle, 40 tick, and then trim it. There, and then delete the circle. That's 40 feet. So same size ticks. So there's the point of tangency, right? The end of the curve. Point of curve, the beginning of the curve. And so I need to mark all these things with the stationing, right? So let's, oh yeah. And then before we could label these things, we had to set our annotation scale nicely. Does anybody remember what we had for that? Isn't it like 1 to something? 2400? So that's 1 inch. It's equal to 200 feet. Yeah. I don't know if that was the right one, so I have to go print. And let's try that scale. So what's cool about this is I have that scale in here now. So I added it, right? And then I could just, you know, or I could just type in 2400 there for crying out loud. So extents, let's pick a nice, you can just set this up right now. PDFer. And the full bleed portrait probably. Let's see what that looks like. Okay, so it's a good guess. Or good, I remember. So anyway, I think that'll work. So I'll add that to my setup. Apply to layout. I don't think I need to. Anyway, just cancel. Okay, so now I know what I'm doing with my annotation. So that one. And then I could, oh, well, we probably don't have a style. So type in the word style. Oh yeah, we have this one, but it's not annotative, and it's this fixed paper text height. So I can put 0 on that and apply.
So nice font. I like that font well enough. Set current.
What is that?
That's stylus BT. I don't know, Bluetooth? No, I'm kidding. I don't know. That's the Bluetooth font, don't you know? Okay, so let's label some of these with that font, I guess. Yeah, it's legible, but it also looks sort of handwritten, so it has a nice little style to it. So I guess that's why they call it stylus, right? Because yeah, I don't know. All right, let's see if we can put a label in there. So this is gonna be 0 plus 0, 0. Oh, the other thing is, let me, no, text size, right? And my new size is gonna be 0.1 inch, right? So that's super small compared to 12 feet, 6 inches, but now that we have it annotated, it should come out just nice. So let's see. 0 plus 0, 0. See, it's all perfect. Let's rotate it. So I click on its grip and then right click to make it the base point. And then I had trouble with this last time, but let's see if I can make it parallel. Not that, not that. There we go. See that? Grab the parallel. There you go. Or yeah, you could use the reference. Thank you. Yeah. Yeah, let's see. Okay. So we rotate it, right? We do the old way. There. Now it's rotating about its own thing. So yeah, you could use the reference and use that line of reference. Or if you're let's see, I can get my cursor close enough to parallel, not too close to the end point or the midpoint to have to track from that. And then there. And so I can see the green mark right there. And yeah, it would have helped if I had zoomed in earlier.
I think it was crosshair.
Oh. Yeah, sometimes that 100% crosshair is kind of in the way, but it's more useful than it's annoying, so I guess we'll keep it. So I'm going to copy this and just edit the text. So we just copy it from base point to endpoint to endpoint. There and there. Okay, we'll stop there. That's the 100 station, 200 station. Okay, so I don't know what this one is, but we can measure it, right? Where's my measure tool? Just MEAS, measure geom, D. And so it's at 425 and 2 3/4 inches. Lovely. So I would actually like to change my units and put it just to decimal inches or something, or even decimal feet, but there isn't one. So that's lame. 2 3/4, yeah. So what do? Go to our calculator. 2.75 inches is that over 12 feet, right? So plus your 25. So that's the number that gets on that. So I would just say, what, 25.23? Stretch that out a little bit more. 4. There you go, 425.23 is right, the point of curve. Oh yeah, and we should probably put PC in front of it, right? The big P. Like that. So this one has a longer, there we go. Put it up there. Get that a little closer. That'll work. Is that okay so far? Questions? I just drew it, right?
Oh,
And then I offset it. And then the last one, I just used the copy command, just to copy from and to the end of the arc, beginning of the arc. Oh, in the fillet command, there's a trim option. So T space, and then you get an option for no trim or trim. Good. Yeah. So this is kind of tedious, I think. You know, if you had a long traverse like this, it would take a while to do all this. Well, there is an automatic way to do it, and we'll go over that. But I want to make sure we get the fundamentals on this one. So we'll just have to bear with it for a minute. Okay, what about along this curve? Like, what's up with that? How do we find out what the next dealio, where the next, yeah, dealio is? The next full station, right? So is 500 along this arc or not? Is that the air conditioner? Okay, one thing I can do is, can I double click that? Can I find the length of this? Oh, I used to be able to double click and pull up the properties. Properties, length, arc length. Yeah, see, this arc length is 223 feet and 1 3/8 inches. Okay, so I do know there's two. So the 500-foot mark is on there, and the 600 is too. I don't know about the 700 yet. I haven't done the math in my head yet. Know what I mean? So if the arc length is 223 feet, I'm going to get at least 2 marks on there. But where are they, right? And that's where the degree of curve comes in. And that's also where we have to know the radius, which we do, right? And it's 200 feet. So we use a little bit of math, I guess. Should we use some math? All right, here's the math. Or should I say maths? Let's show this whiteboard. If you can see that, make a big.
Yeah, text size was
0.1, yeah. Okay, here's the deal. So if we have an arc, right, and it has a certain length, let's say here's the center of the arc. Well, and here's the radius. The radius we want here. It's hard to draw that straight. So there's radius, and then in this case it's 200 feet. We do know what the radius is. That's nice. Tick. Okay. So what's the length? So I know that it starts off at the station value of 425.23, right? Okay. So how do I figure out, how much length I need, right? So for the 500 mark, so what's 500 minus 25.43, right? So 500 minus 425.23. I'm going to get what, 74.77. I did the math right? Sounds right. Can check that. Got my fact checking going on. Okay. So so all I need is 74.77 feet of arc length to get to the 500 station. Yeah. Okay. So how do I get that? Well, remember the formula. This is the formula we're using. The arc length is equal to the radius times the angle, right? So all I got to do is figure out what that angle is, because I already know what the arc length is, 74.77. So let's just pop these numbers in here and solve it, right? 74.77 feet is equal to 200 feet times alpha. Now remember, alpha's in radians, right? So that's okay. So I divide both sides by 200. And I get alpha is equal to whatever that is, right? So a little bit of calculator action going on. I'll just use my phone, so 74.77 divided by 200, and I get, what, 0.37? You check me on that too. 0.37385. Okay, and that's in radians, right? So I probably want to multiply that by 180 and divide it by pi. That's an Excel, right? Or just the Greek letter pi. Okay. So times 180 divided by, I gotta tilt it sideways so I can find the pi. Anybody get it? Kept so used to making those foot ticks. Okay. 21.42 feet. Is that what you guys got? Sorry, that's really kind of angled and sloppy, but we okay with the maths on that? Any questions? Okay. So we'll hop on back to
Okay.
all right.
37385.
Yeah, 0.37385. And I multiplied that by 180 and divided by pi to convert the radians to degrees, right? So I get 21.42 degrees.
Oh, okay, so that's just 0.42. That also is just,
Oh, yeah. I just used my calculator on the pi thing, so I don't know.
okay, so you divide by 200 feet, and then you just converted it to degrees.
Yeah.
Okay.
This eraser doesn't work. Okay. Anyway. So what this means is from this 425.23 station, and I'm going to rotate this angle out here, and here's the 500 station, right? And then this is the alpha. This is the angle between it. Now we've just figured out what the angle is, 21.42. So that makes it very easy. I mean, so really, this happens every time, right? I could take the difference, what the distance I need to make on that arc length, divide it by the radius, and convert it to degrees, and that's my angle. This is how you find the degree of curve, right? The degree of curve is when you find 100 feet of arc length. So that's what I'm going to do next, actually, because we have a 200-foot radius curve, and I want to go to the 600 station, don't I? Yes, I do. So where's the 600? Well, that's 100 feet of arc length, right? And so to the center, this angle is, I'm going to call it big D, right? For degree of curve. So we have the Greek letter delta, which is the entire curve, the angle of the entire curve. We have capital D for the angle that sweeps out one full station, 100 feet. and we have whatever else is needed, right? Like the 74.77 feet. So really, all I got to do, and this is the degree of curve right here. So I'll figure that one out in a minute, but let's go back to AutoCAD. Oh, I bet you, yeah. The screen sharing is paused. Anyway, this is how I'm gonna get the 600 station is by using 100 feet, because there's 100 feet between the 5 and the 6, right? And then I already have my 20. This is what I'm going to do to get the 500 station, is rotate. Well, we'll see. We'll do it. Just going to do it. Okay. So I drew it the other way, but who cares, right? So I'm just going to take this tick mark right there, and I'm going to rotate that. So RO about the center of the curve. And what was the angle? 20 something for, did you guys get 21.42 or 20? Okay, so 21.42 degrees. Oh yeah, and also copy it, right? I don't want to lose the one I have, so C for copy. 21.42 degrees. Oh, select object. There it is. So there's my 500 station. I could also rotate that angle, the text itself with the copy. That'd be fun. Right there. And C for copy. And 21.42 degrees. Oh, no, that's a bad idea. Should have done this one. C for that. I don't know, probably would have been easier. See, now that's totally nice and lined up, perpendicular and all that. And this text is a whole lot smaller. So just go 500. This cord should be away. Okay. Whew. There's the 500, right? Yeah. It's back to the whiteboard. Right. So what's all this? What's 100 divided by 200? Well, that's 1/2. And 1/2 of 180 is 90. So 90 over pi, right? Reduce. So that's an easier calculation anyway for the calculator to get it, Steve. Got to make it easy on your calculator. Did I say 90 over pi? Yep. I close my other calculator. A nice way to, actually, I really should have just used my old Windows calculator. 90 divided by, there's pi. There, that, I'm going to copy that number. Okay. And share the new. Okay. So got that copied. And I'm going to take this tick mark. And I might as well do the text also, right? There's tick mark and text. Rotate. Go to the center. Copy. And now you can't paste that number until you start typing. So I hit backspace a couple times, and now I'm in the type in box. Now I can do a Control V, and there's the angle, and then I can do it. That's pretty tricky, huh? So yeah, if you just go Control V while you're in there, it's going to try to paste that text as into the drawing rather than rotate that angle. So make sure you're typing. You have the cursor. You have their insertion cursor in the flashing in the box where it's asking for the angle, and then you can paste it. Okay. Yeah. What'd you get? Yeah, that's what I got. Sorry, what, Garrett? Did you get it? Okay, so back to the whiteboard. I'm gonna show you. Right? Yeah, this whole thing, yep, just what you said. Exactly. Right? This whole thing reduces to that, right? So this becomes 1/2 of 1/8 90 over pi. After all is said and done. And that's in degrees, actually, right? Because that was the whole thing about pi, is converting the radians to degrees anyway. So. On the calculator?
20.66.
It's right there. Yeah, if you go to View and Scientific, I always do that. It just makes it look smarter. Just and it shows you pi. So, did you find it? Didn't want to show you the answer, but. Yep, nice. So that you can copy and paste into your, AutoCAD for the angle when you're doing it, and that works too. Or you can just type it in. But. Well, there's a couple ways we can do this, right? I can take that 425.23 and then just add the arc length, and that'll be the station value at the end of curve, right? The point of tangency. So we'll do that. So I'm going to pull up my properties again. And arc length is this 223 and 1 3/8. Okay, where's the clear? So 425.23 plus 228. Is that the right length? No, 223, sorry. 223 plus 1.375 divided by 12. So there's the station value, right? At the point of tangency, the end of the curve, right? Yeah. No, let's clear this. Okay. So here, the point of curve is 425.23, right? So let's write that down. So 425.23, and I'm going to add, and that's why I pulled up the properties of the curve here, and I add the arc length, which is 223 and 1 3/8 inches. So I'm going to add 223, and then the 1.375. That's the 1 3/8 divided by 12, right? So that's in feet. There. So
Yeah, put check, is that one?
On what?
Trying to get the 500 on you. Got the 600.
Well, oh, yeah, okay. How much did you rotate it from the 425? So all I did, I started with that tick mark, right? This tick right there, and I rotated it the angle that we figured. What angle are you doing? Where'd you get that?
90 divided by 5.
No, well, okay, so that's for 100 feet of length. Between the 500 and 600, there's 100 feet of arc length there, yeah? But there's only 70, whatever, right? 500 minus 425.23, 74.77 feet. So instead of 90 over pi, you use the 74 over 200, right? The only reason it was 90 over pi is because it was 100 feet of arc length divided by the radius times 180 over pi. This is 74.77 feet of arc length over 200 times 180 divided by pi, which is kind of sloppy here, and so sorry about that. But we ended up with 21 degrees, 0.42, but figure that out. See if you get that number, okay? You do the calculation.
I got 21.42 degrees.
Okay.
The other one was, trying to get the 500.
That is the, yeah, well, okay, I'm not sure I understand you quite.
So the 74.77, that's from 400, or from there to, yeah, so that's from here to here, right?
Yep.
Would be this one?
Yep.
And then the 500 to 6 would be that one?
Yes.
Okay.
Very good.
All right. I understand now. I was kind of confused. You ever figured out the 500? 500 is.
So what do you mean by 500? I guess that's what I'm not sure what you.
Yeah, 500 on the AutoCAD. That's very solid.
Yeah. So the angle between the point of curve, right? This is the point of curve here. The PC to 500. That angle, well, that needed to be 74.77 feet, right? Because that's the difference between 425.23 and 74.77 more feet is 500, huh? So we subtracted those two numbers to get the 74.77, and then we took that arc length and we said that arc length is equal to 200 times the angle in radians. So we divide by 200, that was the algebra right here, divided by 200. And so we got alpha is equal to 0.37385 radians, and then we multiplied it by 180 and divided it by pi, to get the angle in degrees.
So if you want to get did that, 600.
Well, what? Okay, maybe in AutoCAD. Okay, maybe we rotated it from. Make sure you're rotating this guy right here, the PC, right?
Yeah.
And so so rotate it, right? And the base point is at the center of the arc. And then C for copy, so you don't lose the original. And you type in your 21.42. That should work. And that'll get you right at 500.
24? 21.42? Is that,
So I'll just plain old text right here, right? So PT is 6. Well, not 6. 6 plus 40. There you go. Make it nice one-liner. There. Okay. Rotate. Try to get that sucker parallel. Yeah, there's parallel. Except I'm too far zoomed in now. Get parallel. Get away from that. It's too much. Did I pick it up? Polar. There's parallel. Get up parallel. Polar. There's parallel. Dang. Okay. Let me shut that. That's going to be pretty tight here. So that's why 1/10 of an inch text. You could put these on the other side, you know, if it gets too cramped or whatever, just, you know, put it over here. That's okay. You can put the tick mark over there too, for that matter. Don't see any problem in doing that. I typed it. Oh, you mean how did I really get it? Okay, see the point of curve. So all I did was use AutoCAD's properties, right? I selected the arc and I found out the length of the arc. And I started at the PC, which is 425.23, added the length of the arc, in this case, the 223 and 1 3/8 inches, and I ended up with 648.34. So you just add them up. Find what? Oh, yeah. So I just drew a line from the end of the arc to the center and then trimmed it off after I drew a circle at it. Curve, yeah. So any line from the curve to its center is perpendicular to the curve, right? Nice. Yeah, I like that. That looks very nice. Yes. So after you get the point of tangency, we need the next full station, which is obviously on this line past the 648, right? So how far past the 648 are we going to go? And I could just use the offset command because this line is not only perpendicular, because it's the point of tangency, it's perpendicular to the line as well as the arc. So I'm just going to offset this thing, right? Specify offset distance. Well, what's the difference between 648.34 and 700, right? 700 being the next full station. I would say 66. 51.66. Right? Oh, don't forget your tick mark. So O space 51.66 tick. Then I'll set that sucker. There it is.
We just subtracted the 700 from that 640.
Yeah. Yeah. So here, I can just do it right now, right here in the calculator. Maybe not that many. There it is, 51.66, rounded. It's nice to do it in your brain, though. Guess I need zeros there. And there. Okay, more offsetting at 100 feet. So we get to the next curve and do the same thing. Obviously that went too far. Delete that guy. Or actually, I'm just going to move it to the end point or point of tangency. There's my PC right there. So there we go. Off to the races, right? So the rest of the assignment is really just doing that and offsetting the road and getting it done. Get her done. Road center line. So I have this road center line layer. We also have a road layer, which is the edges of the road, the shoulder. Anyway, that's all we're going to do with that is just offset it for the width of the road and call it a day. Then we'll make sure our index contours are thicker and our intermediates are thin and their labeling is good, and then we'll have our assignment, put a border on it. Well, it's already kind of has a border. So we'll just print it to a PDF.